Now we will demonstrate the power of partitioning and layering as we transform our application in 3 ways. First, we'll change the controller and view in the user interface to that of a web application. We are then going to use SQL Server for our data storage. And then finally, we're going to convert the business logic to have a web service front end. This can be done very easily because the way we have partitioned and layered our application. In this screencast, we're going to outline the highlights of this transformation, and the codecast will go into the real details. In our web application, the web page will implement the view. And now that the web page has real events, the controller is called to handle the input. The controller itself is created in the page load. And then the web page delegates the appropriate actions to the controller. And the controller has a set of methods to handle the user interface events, such as add new customer, retrieve by ID, retrieve by name, retrieve all customers, and add order for customer. As before, it uses the view to update the user interface and the model to work with the business logic. The model is completely unchanged because changing to a web application only affects the view and the controller. So because we organized our user interface with the model view controller pattern, it was very straightforward to update it for a new user interface. We went very easily from a console application to a web application. And of course, the rest of the application is unchanged. Converting to a relational database was really very easy. All we had to do is create a iCustomer data map implementation that uses SQL Server. And all it had to do was use the appropriate SQL.data.SQL client namespace classes. The data mapper and the repository automatically use that implementation because of the power of interface space development. They only depended on the interface and not on implementation. Since the interface was unchanged, it didn't matter that the implementation was changed. The only other change that had to be made was in the web.config file, we had to put in the entry for the plugin manager to use the SQL customer data mapper. And of course, the rest of the application was unchanged. The service layer represents the application boundary by defining an interface that represents the access points of the business logic. We have already done this with the iCustomer Manager interface. Each operation on this interface represents a set of business logic tied together by a particular operation. Now, service layers come in 2 flavors. One approach is to use a facade. A facade is a pattern that provides a uniform, higher-level interface to a subsystem. Another approach is to put application logic in the service layer that uses reusable domain objects. For example, in a workflow application, there would be domain objects such as customer, order, and products, but these would be combined in various ways depending on the particular action required. With the iCustomer Manager interface, we have chosen the facade approach. This approach of using iCustomer Manager as a service layer demonstrates that a service layer does not have to be a remote call. However, if you want to use remoting technology, such as a web service or REST, a service layer is the right approach. Distributing objects, as COM and DCOM, Corber and RMI have demonstrated, is not a successful approach. Since we have already constructed the appropriate layer, it is very simple to use Windows Communication Foundation to transform the iCustomer Manager interface into the iCustomer Manager service interface and our Customer Manager class into our Customer Manager service class. Since stateless web services scale much better than stateful ones, we have gotten rid of the Customer Manager factory and instantiated a Customer Manager instance within each service layer call. Now we have to treat the web.config for the service to be our application layer, so we have to add the dependency injection container key into that file. Since the model in the MVC pattern represents the business logic to the user interface, it is the appropriate layer to add the calls to the application's web services. We use a proxy pattern to represent the customer manager's service object in the client's address space, and we use the regular WCF mechanisms to generate the proxy. The model layer in the MVC then becomes a facade to hide the details of the web service plumbing from the user interface. And again, the codecast will have all the details of how this works. So in summary, this unit demonstrated the power of partitioning and layering because we use the existing layers to update the application and evolve the application, and it was very straightforward to do. And again, we'll go over the details in the codecast. So if you understand interface-based design, and if you understand the basics of physical application design, if you have mastered the basics of partitioning and layering, you will see that you'll be able to evolve and upgrade your application in a very straightforward manner.